The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it has spread throughout all tropical regions of the world, transmitting viruses like dengue, Zika, chikungunya, and yellow fever. Today, this mosquito puts more than half the world's population at risk of dengue alone. But we made a breakthrough that changed everything. We found a way to prevent Aedes aegypti from transmitting dengue and other mosquito-borne diseases. Our method uses safe and naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect eggs. Here's how it works. Wolbachia are found naturally in an estimated 50% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch and all offspring will carry Wolbachia. When two insects that both carry Wolbachia mate, the eggs will hatch and all offspring will carry Wolbachia. Over a few generations, the number of individuals carrying Wolbachia increases rapidly until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we would first have to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally, we were successful. And once the mosquitoes carried Wolbachia, they naturally passed it on to their offspring without the need for further injections of Wolbachia. We then took the mosquitoes that contained Wolbachia and infected them with dengue and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be transmitted between people. Our next step was to test the approach in communities where dengue had been a problem for years. Wolbachia mosquitoes were released once a week for 10 to 20 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. Years later, they still do. The results are clear. Dengue cases have dramatically decreased in communities where Wolbachia mosquitoes were released. It is our hope that with continued success, the Wolbachia control method will protect the health of the nearly 4 billion people globally who live with the risk of dengue and other mosquito-borne diseases every day.